Welcome, students. Today, in this lecture, we shall study and try to find out that what is the laser and whether a two-level laser is possible or not. What are the energy levels and what are the rate equations in a laser? So, first of all, let me tell you that as we have already studied, you know that there are two levels or three levels. This is the ground level, this is the excited level, the number of active species here is N1, here the number of active species is N2. Atoms, they get energy from the pump and are lifted to higher level, then there they remain for a very short duration of time usually, and then they make transition to the ground level. Usually what happens, the population of ground level is much more, but in case of laser we recall that there is a metastable level. Metastable state in which the population is more than that of the ground level. So why it is so and why it is necessary? Let us try to find it out. And uh, you see, we can prove it mathematically. So, what is external pumping? External pumping, as we have seen, that there are many pumping mechanisms in laser through a broadband source. Usually, we send a pump signal, and due to this is stimulated absorption. That means absorption is always stimulated by some radiation. It takes place, and atoms are pumped to higher level. So why a two-level laser is possible, is not possible? You see here, and then we see that a question: explain why a two-level laser system is not possible. Now, to prove this, what we can do, we assume two levels, E1, E2, with number density N1, N2 per unit volume in active medium, and omega is the frequency of incident radiation. Then we write the rate of change of number density of excited atoms from level 1 to 2. This is gamma 1, 2. We have already seen this equation. It says that the stimulated absorption coefficient, the rate of stimulated absorption from level 1 to 2, is given by pi by h cross c by omega n naught cube 1 over t spontaneous, that means the spontaneous lifetime, and u is the energy density, and g omega is the line width or the line shift into n1. It is proportional to the number of active species present in the ground level. Then it must be equal to it is proportional to the probability of transition from 1 to 2. That means the rate is proportional to the probability, absorption probability, and we have w1 to n1. Likewise, when the atoms make downward transition, you see that this rate, downward rate, that means stimulated emission rate, is proportional to W21. That means the probability of emission, and also to the number of active species present at that level, that means level 2. Now, it has been already shown in the Einstein equations that W12 is equal to W21. Now, further, we see that the rate of spontaneous emission, that means atoms at E2 also make spontaneous transitions from 2 to 1, that means level 2 to 1. Above we have seen only the stimulated absorption, that means absorption is always stimulated, and stimulated transition to downward direction. But we see that emission can also be, and usually it is it is spontaneous. Atoms at E2 also make spontaneous transitions from level 2 to 1, and there are two possibilities. One is radiative transition, that means some radiation uh, is made in the outward direction, and there is also a possibility that non-radiative transitions are there, which appear in the form of vibration and rotation and such thermal forms. So I assume T21 as the rate of spontaneous emission from 2 to 1, where A21 is the rate of radiative and S21 is the rate of spontaneous uh, thermal transition from 2 to 1. Now, we choose the material such that this is very small. This is very small. Then we have the spontaneous transition as T21 and 2 because again it depends on the number of active species present at level 2. So we can summarize the laser rate equations. Now you see that it is level 1, the rate is dn1, that how it populates or depopulates. Then we have stimulated absorption. So from the ground level, the atoms are being depleted. So the negative sign shows this. And how it is being populated? Next, we see that from level 2 to 1 via stimulated, that means under the under the force of the stimulating radiation, we see that it is being a downward transition is possible, and it is the ground level is being populated. Then we see that spontaneous transitions, they also populate the ground level. And T21, as we discussed, it is the probability, the rate rather, the rate of downward transition, spontaneous one. Now, it is not difficult to understand. Then, when it is a plus, a minus sign, the atoms must go somewhere because the total number is conserved. That means n1 plus n2 must be equal to active species, it is conserved. So it is minus sign, it is plus sign. When it is plus sign, it must be minus because we are getting input from level 2. Similarly, in case of spontaneous emission, when the radiation makes spontaneous transition from 2 to 1, mostly the radiation makes an outward way. So here we try to write the rate equation. The number density per unit time must be equal to, for level 1, that means the ground level, it must be minus W12 proportional to N1 and plus W12 because W12 is equal to W21 into N2 plus T21 getting input from due to spontaneous emissions. Likewise, write dn2 by dt is equals to opposite of this, then opposite of this, because I have no option and I have only two levels, level 1 and level 2. Apart from this, in this case, we have no option. As we discussed, total number is conserved and therefore the rate of change must be 0. So I see that the rate dn1 by dt in magnitude must be equal to dn2 by dt and both must be 0 at the steady state. At steady state, you see. At steady state, both must be 0. So using this fact in the above equation here, we see If I put it equal to 0 and this one also equal to 0, what I get? I get these two equations. So we see that n1 plus n2 is equals to n, and d n1 plus n2 is equals to dn by dt, which is constant, conserved. Then each must be equal to 0 during steady state. So from the above two equations, what we get? W12 n1 minus n2 minus T21 equal to 0. W12 n1, that means this is transformed like this, collecting the terms of n1 and n2. What I get? n2 by n1 equal to W12 by W12 plus T21. Now both of these are positive quantities because these are the probabilities, and now this is less than or equal to 1. So this shows that n2 by n1 must also be less than or equal to 1. This shows that n2 is less than n1. So what conclusion we reach at? That the population of level 2 is always less than that of level 1. That means we can never obtain a steady state population inversion by optical pumping just between two levels. Because what is happening here is one is transferring the atoms, the active species, and another is getting it. So there is no intermediate level in which the population inversion can be maintained, and we know that there is a metastable state in level 3 laser, which is responsible for the laser action. Now we want to find out the population difference by simple mathematical and algebraical manipulation. We obtain at this equation n2 minus n1 by n2 plus n1 equal to this equation, and we see that n2 plus n1 is nothing but the total species, active species, and here we see that by bit of mathematics we obtain delta n by n equal to minus 1 by 1 plus twice W12 by T21. Now we have already seen that this W12 by T21 is equal to pi square by h cross c by omega n1 square. You see here W12. This is all W12 from the Einstein equations, and pi square by h cross omega c by omega n naught squared G omega naught into this is the line width into intensity I. And during the earlier discussions, we have seen that A21 is equal to is inverse of the spontaneous lifetime. So substituting all this, we obtain in terms of intensity. You see, delta n by n equal to minus 1 by 1 plus pi square by h plus omega c by omega n naught squared. Then this is the line width and the intensity. Now writing it in standard form, we see minus 1 by 1 plus I by is g omega. So for a two level laser, I see that the saturation intensity on by comparison is pi square by h cross omega c by omega n naught squared g omega naught. We consider a monochromatic wave of frequency omega equal to omega naught interacts with a two level system. Then because it is monochromatic, we have the line width at that point peak must be equal to 1. There are three possibilities. I is much less than the saturation intensity, I is equal to the saturation intensity, and I is much greater than the saturation intensity. Now in this case, we have delta n is almost independent of the intensity of independent radiation. Here, the difference of populations, that means n2 by n2 minus n1 is equal to minus half of that n1. That means both are equally distributed, and I is much greater than the saturation intensity. Now let us find the loss or gain coefficient. It is defined as alpha is alpha naught 1 plus I by is g omega. For a small signal loss, that is when I is much less than is. The attenuation caused by a medium decreases as the intensity increases to the saturation level. So it is an important information, or uh, it is point which we use in the further 3 and 4 level lasers, because 2 level is not possible, and organic dyes have low saturation intensities of the order of 5 megawatt per centimeter square, and they can be used as saturable absorber in mode locking and Q switching of laser. Students, this I have picked from Ghatak and Tyagarajan, and you please go through it, work out the equations, and justify what we have learned. Now, bye for we shall meet during the next lecture, and we shall discuss about the 3 level laser. Bye for till up till then.